previous lessons, we've talked about implicit differentiation as it relates to taking the derivative with respect to x. So we're usually solving for dy dx. But you don't have to take the derivative with respect to x. In fact, the variable you take the derivative with respect to doesn't even have to be in the equation. For example, if you look at this very first one, it says differentiate with respect to t. And this t is representing time. So it says 2x cubed plus 4y equals 7. So here's the difference when we're doing it with respect to time. 2x cubed, the derivative would be 6x squared, but we have to include dx over dt because we took the derivative of an x with respect to t. That's what dx over dt means. And when we do the derivative of 4y, we get 4 dy over dt. If you remember, we were always technically using these terms. It's just before, when we were doing it with respect to x, we would get dx over dx, which just canceled out and was just 1, so it didn't matter. But now that x is not t and y is not t, they both have to have those terms show up. And before I forget to finish this problem, you would get equals the derivative of 7, which is 0. The good news is you can stop here. You don't have to solve for anything else unless they give you numbers to plug in, which I'll show you one of in just a second. But that's the good news with these, is you're done. That's usually the last step right there. So again, just want to make sure you understand what we're doing. When we take the derivative with respect to t, every time we take the derivative, you've got to put a dx dt term or a dy dt term. And the thing on top is the variable you're taking the derivative of. The thing on the bottom is always going to be dt, or whatever you're doing it with respect to. So in the second one, differentiate with respect to time, we have 3x to the fourth plus 7y cubed equals 9. 3x to the fourth will be 12x cubed dx over dt, meaning you took the derivative of an x with respect to t, plus 21y squared dy dt, because you took the derivative of a y with respect to t, and the derivative of 9 is 0. Now I mentioned there'd be some where you have to plug in numbers, so let's look at one of those. Given y equals x squared plus 1, find dy over dt when x equals 1 and dx over dt equals 2. Before I actually finish this problem, I want to go ahead and tell you the d terms, the dx dt and the dy dt, represent rates of change. So dy dt represents the rate at which y is changing. Dx dt represents the rate at which x is changing. So as we do this, we're wanting to know how fast is y changing when x is equal to 1 and is changing at a rate of 2. And that can be any unit you want. It can just be 2 units per minute, or 2 units per hour, or 2 feet per second, or it depends on what our equation represents. So we need to take the derivative with respect to time. The derivative of y is just 1 dy over dt. The derivative of x squared is 2x dx over dt. And then the derivative of 1 is 0. So we have this equation. Now it says find dy dt when x equals 1, so I'll plug in 1 for x, and dx over dt equals 2, so I get that. So I find out that dy over dt is equal to 4. So that's how you take the derivative with respect to time.